Hi, I'm Joshua Lee, and in today's video, we will be learning about 2D kinematics. If you remember, my first video was about kinematics and the basics of it. So I recommend watching that video first, since we're going to be solving problems using concepts from that video. In this video, we'll mostly be solving problems, and I'll explain along the way. But remember to watch that first video. Okay, I trust that you've watched my other video, so let's start with the review. A ball is tossed straight up into the air with a speed of 20 meters per second. Now, how far up does it go? For this question, we'll assume that your hand starts at 0 meters. We'll also neglect air resistance. Let's make a list of knowns and unknowns. We know the initial velocity, which is equal to 20 meters per second. We also know that the final velocity is going to be 0 meters per second. Now, if you think about it, at the ball's maximum height, it will have no kinetic energy. So that's why it's 0 meters per second. Now, the acceleration here is going to be negative 9.81 meters per second squared. Now, this is because this is the acceleration of gravity. And it's negative since gravity tends to pull things down relative to our view. We want to find out distance or the displacement. In this example, they're the same, so we can use either one. So it's going to be question mark. We need to use the equation Vf is equal to Vi plus At to find out the time it took. Now, if we substitute the values, we get that 0 meters per second is equal to 20 meters per second plus acceleration negative 9.81 meters per second squared times time. Now this becomes negative 20 meters per second is equal to negative 9.81 meters per second times time. We can divide both sides of the equation by negative 9.81 to get that the time was roughly 2.04 seconds is equal to time. Now, what do we do with this time? Well, we can substitute it into the equation d is equal to Vi plus Vf divided by 2 times time. We don't know the distance or displacement, so it's the unknown here. The Vi is going to be 20 meters per second plus 0 meters per second, and then divided by 2 times time, which is 2.04 seconds. So this becomes 20 meters per second divided by 2 times 2.04 seconds. So d is equal to 10 meters per second times 2.04 seconds. So the final distance we get is that d is equal to about 20.4 meters. But this question only deals with one dimension. What if we add another dimension? This is where 2D kinematics comes in. Let's start with a basic example. Now, there's a human standing on this cliff. He runs to the edge at 5 meters per second. Now this is water, so he's safe. Now let's say his velocity is completely vertical, so he doesn't jump, but rather just runs straight off. Now, then his path will be something like this. And then here he'll hit the water. This cliff is 30 meters tall. Now, the question is, how far will he get from the base of the cliff? In other words, how far is this distance? When dealing with motion in 2 dimensions, it's important to understand that horizontal motion and vertical motion are completely independent of each other. To prove this, we can try a simple experiment. Imagine you have 2 identical balls. We put them at the same height. One of them will be dropped straight down, while another will be launched sideways, perfectly horizontally. Since horizontal and vertical motion don't affect each other, both balls should land on the ground at the same time. This may be a bit counterintuitive because the second ball has a longer distance to travel. So what does this have to do with our example? Well, it means that since this person started off with 5 meters per second of horizontal velocity, and since horizontal and vertical motion don't affect each other, this person is always going to have a horizontal velocity of 5 meters per second, neglecting air resistance. So the horizontal velocity will always stay the same until the person hits the water. Now what about the vertical velocity? Well, the vertical velocity will get greater and greater, or lesser and lesser, since you're going in a negative direction, but you're going to go faster and faster downwards. So in other words, you're going to be accelerating downwards. So as we always do, let's make our list of knowns and unknowns. Since there's two axes, we split it into x and y components. So here will be our x in blue. We know the initial velocity, which is equal to 5 meters per second. We don't know, and we want to find the x displacement. So that's a question mark. Now here, distance and displacement are the same though. Let's go to the y. So y here will be in red. We know the y initial velocity, which is 0 meters per second. Now some of you may be confused since the question says 5 meters per second. However, this is horizontal velocity, and since there was no initial y velocity, the initial velocity will be 0. Now we know the x displacement too, which is negative 30 meters, since he goes down the cliff. We also know the acceleration. Now the acceleration is going to be negative 9.81 meters per second squared. Now this is because since the human is traveling down, he's going to be affected by gravity, which has an acceleration of negative 9.81 meters per second squared. You also need to include the negative, since gravity pulls down relative to us. Now time is going to be same for x and y, so we should look for time. We don't know the final velocity and don't want to know it, so we should try to use a formula that doesn't involve final velocity. We can use the equation d is equal to vit plus 1/2 at squared, because this doesn't include final velocity. Now it's important to note that when you're solving a problem with more than one dimension, you can only use values from the same dimension in the same equation. So in other words, you either have to have all x values or all y values. In this case, we'll be using all y values. So we have negative 30 meters is equal to the initial velocity, which is 0 meters per second, times time plus 1/2, and the acceleration negative 9.81 meters per second squared times the time squared. So we can simplify this as negative 30 meters is equal to, these cancel out since time times 0 will be 0, and 1/2 negative 9.81 meters per second squared and times time squared. And this is equal to about negative 4.905 times time squared. So if we divide both sides by negative 4.905, we get about 6.12 is equal to time squared. So now we can take the square root of both sides and find out that the time is equal to about 2.47 seconds. Now we need to take this time and substitute it into an x equation so we can find out the displacement. We can use the same equation but we're using x values. So d equals vit plus 1/2 at squared. So we can use the same equation but use the x values. Since we know everything except for the distance here, we can find out what it is. So this becomes distance is equal to vi, which is 5 meters per second, times time, which we found to be 2.47 seconds, plus 1/2. A is going to be 0 since the velocity will be constant. at least for horizontal velocity. 0 times time squared, so that's 2.47 squared. So this will be equal to d is equal to 5 meters per second times 2.477. So the final distance will be about 12.4 meters. Now that's math I did beforehand. I didn't do that off the top of my head. Let's try another example. But this time, a projectile will be launched into the air. Let's say I'm standing here and I throw this ball at a 30-degree angle to the horizontal. So 30 degrees. I throw it at a speed of 10 meters per second. Again, we'll assume that there's no air resistance and that my hand is at 0 meters up in the air. Now that's unrealistic. Well, we can't just use this vector as it is. We have to split it into its horizontal and vertical components by creating a right triangle using the vector as its hypotenuse. So we have this vector here. So this is 10 meters per second. And here we have this triangle. It's a right triangle. Now this here is 30 degrees. These two legs are the components. So this will be the x component or the horizontal component, and this will be the y component or the vertical component. Let's start by finding the vertical component. By the way, this uses trigonometry, so if you haven't learned it, you should first learn about it. Since this vertical component is opposite the angle, we should use sine, since we need the opposite and have the hypotenuse. So since sine is equal to opposite over hypotenuse, sine 30 is going to be equal to this vertical component, I'll just put VC, and over the hypotenuse, which is 10 meters per second. So if we multiply 10 to both sides, 10 sine 30 will be equal to the vertical component. So the vertical component is going to be equal to 5 meters per second. So this here is 5 meters per second. So this means that the initial vertical velocity is 5 meters per second up. So it goes up at 5 meters per second. Then it travels, and just before it hits the ground, the final velocity will be negative 5 meters per second. So let's find out the change in velocity. Well, to do that, we just subtract the initial velocity from the final velocity. So that will be negative 5 meters per second minus 5 meters per second, which is equal to negative 10 meters per second. So that's our change in velocity. Well, what do we do with this information? Well, the change in velocity is equal to the vertical acceleration times time. And we know that acceleration is going to be negative 9.81 meters per second squared because of gravity. So negative 10 meters per second is equal to negative 9.81 meters per second squared times time. So we can divide negative 10 by negative 9.81 and get that the time is equal to about 1.02 seconds. So now let's go back to our triangle and figure out the horizontal components. Since it's the adjacent side, we need to use cosine. So cosine is equal to adjacent over hypotenuse. So cosine 30 will be equal to the horizontal component divided by 10 meters per second. So 10 cosine 30 will be equal to the horizontal component. Now, the horizontal component then is about 8.66 meters per second. So let's label that. Okay. So now we can find out the x displacement slash distance. We can use this equation, VI plus VF divided by 2 times t. Now, if we think about it, this is just the average velocity, and this is the time. So we know that the average velocity is 8.66 meters per second, or at least the horizontal average velocity. So this will be the distance is equal to 8.66 meters per second times time, which is 1.02. So the total distance traveled will be about 8.83 meters. Now, most 2D projectile motions will be similar to the ones we did today, but with different numbers. 2D motion is similar to 1D motion in many ways, but just a bit harder. I hope you enjoyed this video. Please subscribe and thanks for watching.